Alright guys, this is our practice final for Algebra 2 fall semester. So problems 1, 2, 3, and 4 here. We're going to be using f and g here. So the first two, very simple, is figuring out, hey, what's f of 3? Take the 3 and we're going to plug it in for the x here. So that would be 3 squared minus 1, which is going to be 9 minus 1, which is going to be an 8 for us there. Over here on g, we're going to be plugging in 23 for the x here. So it'll be giving us the square root of 23 plus 2, which is going to be square root of 25, which is going to be just a 5 for that one. So those two, again, fairly simple, just kind of making sure, yeah, we understand these basic properties of the notation and how we can plug things in and do some basic algebra steps there. On number 3, we're saying, hey, well, what's x when f of x is 15? So this is different than this. We are not going to plug in the 15 for the x. We're going to say, well, set this f equal to 15. So that's x squared minus 1 equals 15. And add over the 1, I get x squared equals 16. I'm then going to square root both sides. And I get x is equal to plus or minus the 4. And the big thing that people always miss here is that plus or minus. Whenever you are square rooting both sides of any equation, you need that plus or minus, or you're only giving half of the answers there. Then over here, we have g of x is equal to 6, so set 6 is equal to that. So 6 equals rad of x plus 2. So we're going to square both sides to get rid of that radical. It's going to be 36 is equal to x plus 2. Subtract 2, and we're going to get that x is 34. So again, those ones should be fairly easy, fairly give me problems. Most of the errors that I ever see there are just little tiny things like negative signs, or you did 2 plus 2 is 5, something dumb like that. So looking down here on 5, this is where we're going to be trying to create the equation of a parabola that meets these criteria. So we can place this wherever we want it. We have a horizontal distance of 30, a height of 12. So I'm going to start mine. And you want to draw the picture so that I know what equation you are finding. You are either going to center it here or center it where our vertex is actually on the y-axis. Whatever you prefer, they both work just fine. But I'm going to show this method here. I know that my vertex is going to be at 15, 12, because I'm over half of that distance of 30. This is the point 30, 0. This is the point 0, 0. So my equation would be y is equal to a times x minus h squared plus k. Well, my h and k are going to be 12 for h and 15 for h and 12 for k. And then I'm going to need to plug in another point, either one of these other ones which I know, into x and y, and then I can solve for that a. And that a is really where all of the work in this problem is, because otherwise I just plug in h and k and I'm done, right? So I'm going to use the 0, 0 point because it's just a little bit easier for me. A times 0 minus 15 squared plus 12, right? So then we're going to do 0 is equal to a times 15 squared is going to be 225 plus 12. We're then going to subtract that 12 over to the left-hand side. Negative 12 equals a times 225. We then do negative 12 divided by 225, and we get the fraction that a is negative 4/75. So once I have that, it's just a matter of plugging that in to my equation. That would be y is equal to negative 4/75 times x minus 15 squared plus 12. And there would be my equation. Nope, you can't see it. There we go. All right, let's jump down to 6, 7, 8. So on these ones, we're trying to sketch a graph. Now, the default, which you can always do for graphing anything, is plug in a whole bunch of points and try and get the shape as best as you can. Right? I do not recommend that. That's way slower. All I really care about here is, do you know where the locator point is, and do you know the general shape of the graph? So this one here is going to be a quadratic. This plus 1 is going to move it to the left 1. So my locator point is right there on the x-axis at negative 1. And then that 2 is going to make my parabola appear taller. So it'll be a lot more narrow as it goes up. Now I don't really care about it being specifically going through certain intercepts, things like like that. Again, what I want to see here is your locator point in the right spot. Does it look like a fairly slender parabola graph, right? If like you drew it crazy wide, like wider than a normal quote unquote graph, that shows me, hey, that's the wrong thing. So just try and show me, hey, here's what is going on. For here on 7, this is going to be moved to the right 3 from that minus 3, and then up 4. So right 3, 1, 2, 3, up 4, 1, 2, 3, 4. There's where my locator point is. And then it's just a standard cubic graph, which is going to be doing that on this side, and then it'll do that on this side. Now, is my graph perfect? No, but I have the right locator point. I have the right shape. We're good to go there. Then looking over here at 8, I have a rational. So this plus 3 is going to move it to the left 3 and then down 1. So 1, 2, 3, down 1. That's my locator point for the rationals. Now that locator point on a rational tells me that my vertical and my horizontal asymptote go through that point. Okay, and then that 2 is going to make it seem a little bit more tall. So it's going to be that standard kind of corner shaped graph here. That's being kind of vertically stretched a bit. So it'll look like that, and then like that. And it's a little harder to kind of show that vertical stretch, but what I care about mostly is going to be, once again, the shape and that locator point for it. All right, heading on to the back side here. So here off there, okay. Number 9. So we're trying to complete the square here. So if you know the shortcut and you can do it without the picture, awesome, go ahead and do that. I'm going to show you with the picture, because if you need help on that, that's probably the level you're still at. So I'll draw out my box. So here's my x squared box. Now my negative 8x's, I need to put half of them here and half of them here. So I'll do 1, 2, 3, 4. 1, 2, 3, 4. And then I have this big area here. Now I could draw in all those individual ones, but it's 4 by 4, so there's going to be 16 total ones in that little box there. Now I currently have 3. So I have 3 of them. I'm short all of the rest. So to fill in the box to complete the actual square here, I have to add 13 more. So that 3 plus the 13 that I'm adding will fill out the rest of the actual square and quote-unquote complete the square. But I can't just do that. I have to balance it out by subtracting it off on this side as well. So all of this is my square, which is x by negative 4 by x minus 4. So x minus 4 times x minus 4 is just x minus 4 squared, hence it being called squared because it makes the actual square, right? And then I had that plus, the minus 13 on the outside, and there is my graphing form. Right, so again, if you prefer doing it with the just looking at it algebraically, and you can do that, awesome, great. It's a little bit faster, but if you still need to draw the picture, it's really not that bad and not that much work. So don't feel bad doing that. Okay, down here to 10 and 11. All right, so we're trying to determine if the following pairs are equivalent. So here, this would really be 3x minus 1 times 3x minus 1. So then when I FOIL it out, I would get 9x squared minus 3x plus 1. So that would be 9x squared minus 6x plus 1, which is different than what I'm getting here. What they're doing is the very, very common mistake that drives every math teacher mad, and they're just saying, well, I'll just go and square that, and then call it good, right? Which we can't do, so these are going to be not equivalent. Right, on 11, so over here, I see 8x plus 3y equals 9, and then y equals this. I'm not in the same form, so let's try and get them in the same form. So I'm going to take this and make it look like this. So I want to get that y by itself. So I'm going to subtract over the 8x. So I'll have 3y is equal to a negative 8x plus 9. I then need to divide by 3. So I'll have y is equal to negative 8 over 3x plus 3, because I have to divide all parts by 3. And then this ends up being the exact same thing there, so they are equivalent in that case. And again, you can write equal however you just show me that yes, these are the same and these aren't, stuff like that. All right, down to 12 and 13. So these are probably the ones that take the most time. These are ones where it's a whole lot about factoring. If you can factor well, these are going to be cake. If not, factoring is the biggest, hardest part about all of these. So top left here, I'm going to want to do my little box method on this one to try and factor that. So 2 times negative 2 is going to be a negative 4 on top, and then a 3 on the bottom. So I need two numbers that multiply to be a negative 4, add to be a positive 3. So that's going to be a 4 and a negative 1. So then when I do out my box, this would be 2x squared, negative 2, 4x, negative 1x. I can pull out a 2x, I can pull out a negative 1, I can pull out an x, I can pull out a 2. So the top there is going to factor into 2x minus 1 times x plus 2. All right, now the bottom. The bottom is the difference of two perfect squares, x squared minus 9. So that would factor into x plus 3, x minus 3. That is a pattern you should know. If not, just take a look at your notes or look up difference of perfect squares factoring, and you should see and get refreshed on how that method works. Then over here on the right hand side, I do not have a number in front, so I can do that little shortcut way of factoring here. So what multiplies to be negative 12 adds to be positive 1. Well, that's going to be a 4 and a negative 3. So that would be x plus 4 and x minus 3 is what it factors into. And then on the bottom, I have 6x minus 3. I can do a greatest common factor of 3 there. So I'm going to pull out a 3. And what I have remaining is going to be 2x minus 1. So now that everything is as factored as it can possibly get, and one thing that a lot of us missed on the last test was greatest common factors. Always look for greatest common factors, even at this step here. Look for, do any of these factors have the greatest common factor, which I could still pull out, because a lot of you guys didn't get it fully factored because of that one little small bit there. Okay, so now it's all being multiplied. So I could rewrite it as one big fraction, but I'm not going to waste time doing that. I'm just going to start to cancel out now. So I have 2x minus 1 here and here, x minus 3, x minus 3. Nothing else here is going to cancel out. So it's going to be x plus 2 times x plus 4 over 3 times x plus 3. And we typically just write constant numbers off in on the left-hand side. There's no other real benefit in me doing that. So there we go. Last thing that I want to do is figure out, hey, what values can x not be? And that would be anything which would make the bottom of any fraction 0. So x in this case could not be a positive 3, a negative 3. That doesn't matter. And then here would be a 1/2. So those are my values which x could not be in this case. All right. Looking over at number 13, it's the same type of problem, but it's division, so all we have to do is flip that right-hand side, and then it's just like the last one was. So I'm going to factor the top left here, so I'll do my little move so we can see the whole page, so I can use all of it. Okay, so I'll do my little x over here. 3 times negative 5 is going to be negative 15, and then I have a negative 14 on the bottom there. So I need two numbers that are going to multiply to be negative 15, add to be negative 14. So that's going to be a negative 15 and a positive 1. So then when I go to my box, 3x squared here, negative 5 here, do negative 15x and a 1x. So I can pull out a 3x here. I can pull out nothing but a 1. Here I can pull out an x, and here I can pull out a 5, but it needs to be negative. So that top left there, I'll kind of draw this so it's separate, is going to be 3x plus 1 times x minus 5. Right? And then on the bottom of my fraction, I'm going to do the same thing for the bottom part here. Draw out my x. 4 times 3 is going to be 12. 8 on the bottom, so I need two numbers that are going to multiply to be 12, add to be 8. Well, that's going to be 6 and 2. So draw out my box here, and I get 4x squared, positive 3. It's going to be 6x and 2x. I can pull out 2x. Here I can pull out nothing but a 1. Here I can pull out another 2x. Here I can pull out a 3. So the bottom is going to factor into 2x plus 1 and 2x plus 3. All right. I'm getting a little lower, but I should be able to kind of squeeze things in on this side. So on the top here, I can do a greatest common factor. I'm going to be able to pull out a 2x, so that would be 2x times 3x plus 1. And then on the bottom there, I can pull out another 2x. That would be 2x times be 2x plus 3, right? But then I have to flip those to make it multiplication, so it would be times 2x over 2x plus 3 over 2x times 3x plus 1. So now it's all being multiplied. I can start to cancel things out. Well, right off the bat, these 2x's are going to cancel. 3x plus 1, 3x plus 1, 2x plus 3, 2x plus 3. So all I'm left with is x minus 5 over 2x plus 1. Right? Now I do need to also look for what's going to cause the bottom of any fraction to be 0. I need to check this, 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 and then also this and this before I flipped it over. So I really got to check all 6 of those. A lot of them are going to double, but I still want to be checking them. So x cannot be, this would be a negative 1/2. This would be, that's plus 3, so that would be a negative 3/2. X cannot be 0 from that. It cannot be a negative 1/3. And up here, that's another 0, and then here is another negative 3/2. So I already have all of those covered. So that is what I cannot end up having. All right, so that is it for our review for our test. Good luck, and I'll talk to you guys next time.